So I just received this email with this block of text of these random numbers and letters. Like, what could this possibly mean? Hold on. If I click this button, whoa, it's a secret message. My mind's exploding. Oh man, brains are all over my walls. No, this is PGP encryption. And in this video, I'm going to show you how you can send and receive encrypted messages using open source software. In my opinion, this is one of the most important privacy tools that you can use. It's great because you are using encryption on your own terms. And, all the time I read about people, requesting what's the most private email or what's the most private messaging protocol, and that's all well and good. But how about instead of relying on some other application to be private for you, you can be private on your own terms, fully understanding everything, and you can therefore receive and send messages that are 100% encrypted. So I'm going to show you how you can do that in this video. So we're going to start things off with a real-world example as to how I use PGP. And to illustrate this, I'm going to send a PGP encrypted email to Sam Bent, who is the creator of Doing Fed Time, which is a fantastic YouTube channel about privacy and OPSEC and all that good stuff. Well, I'm not going to actually send him an email, but I'm going to show you how I would go about doing it. So this is his website, and on his website, he has a public PGP key. And we need to get this because we can use somebody else's public key to encrypt PGP messages that we can send to them that they can decrypt, okay? So basically, when you are having a correspondence with somebody with PGP, you both need to have the public key of the other person that you are sending messages with. And in doing so, if I provide my public key to, in this case, Sam Bent, he would then be able to encrypt messages to send to me that I could later decrypt. And I'll show you how I can decrypt that in a few minutes. So anyways, we have his public PGP key here. I'm going to click on it. And yeah, it's just a blob of text. And, it's important that you want to copy also this top line and this bottom line. That's a begin PGP public key block. And also when you send messages too, you want to make sure you copy that because it's actually part of the message. So in this case, we're just going to hit copy down here, and it's going to copy the PGP key in our clipboard. It's important to note as well, a lot of people, they put their PGP keys in a text file. Like for example, on my website, antimoonboy.com, I have my PGP key in a .asc file, it's a text file that holds PGP keys, and literally all you would have to do is just import that into whatever key ring that you have on your computer. And so yeah, once you have the public key of the person you want to send a message to, you're going to then import that public key into whatever application you're using for PGP. Now I am using Cleopatra. It is a free and open source GUI, which stands for Graphical User Interface. And yeah, basically it is a really great tool for sending PGP messages and also verifying. And I'm going to talk about what verifying is in a second as well. And yeah, I would recommend Cleopatra if you're using Linux because it's Linux only. However, for Windows, I would recommend GPG4Win. And there's also a Mac version for it as well. I'll put an image in the video to show it. But basically, you're going to want to get a free and open source application that you can trust. And in this case, Cleopatra is pretty well known, and GPG4Win is also pretty well known. So there's going to be some slight differences in the layout of what I'm doing versus what you might be doing, but it's basically the same thing as you're about to see. So anyways, we're now going to import the public key. And again, if you downloaded a text file, you would just click import here. In this case, because I have it in my clipboard, I go, let's see, to Tools, clipboard, and then certificate import. So I'm importing a PGP key from my clipboard. And it's going to ask me if I want to certify this. And I'm going to say yes. And there we go. We have the PGP key from Sam Bent, and we have the fingerprint for him, and we're going to certify it, and there we go. So yeah, fingerprints are kind of like an easier to read verification of who somebody is. Again, we're going to talk about that in a second, but for now, just know that we've verified that it is the person we want to send an email to. So let's write him an email. So I'm now going to click encrypt for others, and we are going to select Sam Bent. I'm going to say, hi, Sam. I like your videos, smiley face. All right. So now I am using the public key that I have in my key ring, or my database of keys. And then I'm going to hit encrypt notepad. And boom, I now have a PGP message. So what I would do is I would copy this entire thing, and I would send an email and include this text, basically. And then Sam, what he would do is he would receive this message and he would decrypt it with his private key. Okay. So when you create a PGP key pair, you create a private PGP key and a public PGP key. Obviously, you don't share the private one, right? Because that is your secret key to decrypt PGP messages. So Sam has that private key, so he'll be able to decrypt this. I actually can't even decrypt this message, even though I just created it. If I click decrypt here, it says, failed to decrypt the notepad, no secret key. Yeah, I don't have the private key, so I can't decrypt it. So even though I made it, it's something I can't go backwards on, right? It's a one-way street. So a lot of this, it seems kind of abstract, but it's very similar to cryptocurrency, right? You have wallet addresses that people can send cryptocurrency to. That is your public key, right? But with your private key, you can actually access your money and then, send your cryptocurrency, right? So it's different. Like, other people don't have your private key, and obviously you wouldn't share your private key. But in this case, we have the public key of somebody else, so we can send them messages that they can decrypt. So now let's actually make a key pair. So I'm going to click File and New Open PGP Key Pair. So for the name, you want to choose something that people can recognize. So I'm just going to say practice, because we're just practicing here. For email address, you would want to use your email, your public email. But in this case, I'm just going to say practice@antimoonboy.com. You can put a password on here, which we're not going to do. Now for advanced options, we're going to choose the RSA 4096 key. I think this is the strongest one. This is what I've been using. So I would recommend that. And for this down here, you can actually choose a expiration date for your PGP key, in that once this date comes along, we will want to rotate our keys and actually just make a new PGP key pair. So I'm actually going to leave that here. You can also uncheck this. Doesn't really matter what you choose. You can also customize the date that the key is no longer valid, but we'll keep it for 3 years. Okay. Then we hit OK, and there we go. We have a new PGP certificate and the fingerprint of that certificate. So now what we're going to do is we are going to send that message again, but this time we're going to encrypt it for both us and Sam. So again, hi, I like your videos. Okay. And now I'm going to encrypt down here. And yet again, we get another random blob of text. However, if I click decrypt now, I can decrypt the message. And that's because I encrypted this with my public key, along with the public key of the person I'm sending the message to. So yeah, this is pretty cool, where with PGP messages, you can actually encrypt it with multiple public keys, and therefore you can decrypt it with multiple secret keys. So in this case, the only two people who can decrypt this message are me and Sam Bent, because we both have the private keys associated with the public keys that were used to encrypt the message. So I clicked on certificates here, and I pulled up my practice PGP key. And one thing I can do here is I can export, click export here. This would actually export the public key that I have. So I created a test file here. So I'm going to save this in this test document file here, and I'm going to open it up. Okay, and I'm going to hit enter. And there you go. There is my public PGP block. That's basically what I did. Is I just, this command is to show what's in this text file. This is what's in that text file. So if I were to send an email to Sam, what I would do is I would include that .asc file that I have in my folder. I would include that as an attachment in the email. So then that person would be able to then reply to my email with an encrypted message that I can unlock. Also, what you can do is you can back up your secret key, which I do recommend you do on an encrypted hard drive. So you can take your private key and you can store it somewhere safe in case your computer, explodes or something. You will have a backup so that you will still be able to decrypt messages that are sent to your public PGP key. Now, there's one other thing that I haven't really shown, and that is signing a message. So signing a message is a way to verify that you are sending a message. And I encourage that you always sign messages if you can. I didn't on the past example, but I am now introducing the concept to you now. So, for example, let's say I create an Instagram account for Anti Moonboy. So what I can do is I can send out a message to different people, confirming that I am the person behind that account. So for example, if this practice PGP key pair was my official PGP key, I would say something like, the Instagram account Anti Moonboy is mine. Right. So then what I would do is I would check this box. I would sign it, and I would sign it with my key. And then I just hit down here, sign notepad, and boom. I have the message here, and it's surrounded by encrypted stuff, right? Now, here's the subtle difference here. So what happens now is that if somebody has my public key, they can decrypt this message. So this is something that isn't decrypted by a private key. It's actually decrypted by a public key. Okay, so if I hit decrypt here, I will be able to decrypt the message. And when I click it, it says a signature created by practice@antimoonboy.com, and the signature is valid. So really what I did here is I decrypted the message with the public key that I have stored on my system. And likewise, if you had previously downloaded my PGP key, you would do the same thing. So the distinction here is that that secret message is made only by someone who has the private key. And later on, it can only be decrypted by someone who has your public key. Okay? So this is a really easy way to prove that you're behind a message. So generally speaking, whenever I send somebody an encrypted email, I always sign it, which you should do, because it proves that you're the person signing it. Otherwise, let's say your email became compromised, somebody can send an encrypted email to, like in the previous example, to Sam Bent. They can just send an encrypted email, but because it's not signed, it's less trustworthy, right? Now, still technically you can compromise a PGP key as well, so it's not a perfect system, but this is just an extra layer that you can have to verify authenticity. So for example, if I add the encryption for myself as well as Sam Bent in this example, let's say I'm telling Sam that the Instagram account is mine, I can then go back here and sign and encrypt the message, and boom, it's just a block of text here. And then when I hit decrypt, the entire thing is decrypted because I am decrypting it with my private key and verifying it with the public key I have on my system. Oh, one other subtlety too is the signed message that I showed initially where I just signed it. So I can actually go back here. Oop. Okay, if I were to just make this message and just sign it, this is actually completely readable, right? So when you sign a message, it's a message that anybody can read on the internet. But again, you can only confirm it if you have the public key. So the last example we're going to go through is verifying the authenticity of a download. And what you can do is you can do this with PGP, and I'm going to show you how. So I'm going to download the official Monero GUI wallet, and then I'm going to verify its hashes. Sounds complicated, but it's actually really easy if you just use PGP. So I'm using Linux, so I'm going to download this. And next, down here, they have a section of verifying. And they have a text file that you can download. So I'm going to make a tab for that. And then they have a guide for verification. So we're going to click on this. And down here we find the GPG key of the developer, a binary fate, who is going to sign the hashes. Now, GPG and PGP are used interchangeably. GPG stands for GNU Privacy Guard, whereas PGP stands for Pretty Good Privacy. It's the same thing, okay? So it's a little confusing. You can use the internet and figure out why it's different. But anyways, we're going to just tab this out, and we have this public key block. So we have the signed message here with the different hashes, and it's signed by Binary Fate, who is the developer. And here is Binary Fate's public key block. So what we're going to do is we're going to copy this message. We're going to go back into our notepad, and we're going to clipboard, certificate import, and there we go. Now I've already imported Binary Fate's PGP key, but that's how you would go about and do it, right? So we have the public PGP key, and now we're going to copy this signed message here. So we're going to copy this, going back here, and then we're going to copy paste this signed message. And now I'm going to hit decrypt/verify, and you'll see I verified the message. Signature created on 4/5/25 with certificate Binary Fate. So I verified that that is an authentic message by this person that I trust. Okay. So what do we do now? Well, we're now going to get the hash of the download that we just did. Okay. So again, it depends on the application you're using, but I'm going to say file and then create checksum files. And then what I'm going to do is I'm going to go into that folder I made, and I'm going to click the Monero GUI Linux one, and I'm going to hit open. And it says that successfully created checksum files. Okay. So now I'm going to open that file. So cd, and let's see here. Okay, so it's in this SHA-256sum.txt file. So I'm going to hit enter. And again, this command is just revealing the contents of this text file that's in that folder. And we see here that the content of it is E276F9, blah, 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 blah. And so what we can see here is that Linux file that I just downloaded right here has that hash that matches the SHA-sum. So to summarize, I imported the public PGP key of Binary Fate, who is the individual responsible for signing the official hashes of the Monero downloads. Okay, I imported his key, and then I went into the Monero website, which has the hashes for each of the downloads. I copied that signed message, right? So we can go back here. Initially, this is what I copied, where it said the PGP signed message. I copied the entire thing, put it in my PGP application, and then I hit decrypt here. And once I did that, it verified that the signature matches the PGP key I already had imported. So I know that this is an authentic message. Next, I went to the actual wallet download that I had, and then I found the SHA-256 sum of the wallet download. And this is important too, because if there were any sort of manipulation done, like for example, if there was a bad actor who, hacked something and they put in malware into the download that I just made, this SHA-256 sum would be different if that person were to put in malware, okay? So because this matches what the signed message has here, I can confirm that the download that I made was not touched or manipulated in any way, and I can feel safe now going through the process of opening that archive file and extracting the contents of it. But basically, that's it. So PGP is an incredibly useful tool that is very important to know, where you can send encrypted messages, you can receive encrypted messages, but you can also verify authenticity of things. And a lot of times your computer just does this without you even realizing it. And it's very important with the internet these days that you can verify that you're talking to the right person. Because for example, if somebody were to be impersonating me in some chat room, you can say, okay, send me a signed message from Noob PGP. And if they're unable to do that, you're talking to somebody who is pretending to be me. Okay? So if you like the content, subscribe and leave me a comment or whatever, and stick around because I will be making more beginner content like this.